Hello, good afternoon, everyone. So, in the last class, we have seen all the five modules, 2 marks questions. Oh. Sorry for the inconvenience. So, now we will see 8 marks questions. So, I am sharing the screen. I hope it is visible to you. In define site investigation. What are the different objectives for which site investigation is done? Site investigation is done for obtaining information about subsurface condition at the site proposed construction. So, what is site investigation? So, some of you told that you have some doubt regarding module 5 2 marks question. So, I will repeat it before moving forward. So, how you will define anchor piles? Anchor piles are used to encourage against horizontal pull from sheeting pile or other pulling forces. So, how we are defining anchor piles? Anchor piles are used to encourage against horizontal pull from sheeting pile or other pulling forces. Instead, the use of compaction piles. So, what are compaction piles? Compaction piles are used to compact loose granular soils in order to increase the bearing capacity. So, what are compaction piles? Compaction piles ऐसे piles हैं जो कि यूज किए जाते हैं to compact loose granular soil in order to increase the bearing capacity. Water end bearing piles. How you will define end bearing piles? End bearing piles are used to transfer load through the pile tip to a suitable bearing stratum, passing soft soil or water. So how you are defining end bearing piles? End bearing piles ऐसे piles हैं जो कि यूज किए जाते हैं to transfer load through the pile tip to a suitable bearing stratum, passing soft soil or water. So list the uses of laterally loaded piles. The uses of laterally loaded piles. The uses of laterally loaded piles are to support horizontal or inclined forces such as foundation of retaining walls, bridges, and dams. So what are the uses of laterally loaded piles? The uses of laterally loaded piles are to support horizontal or inclined forces such as foundation of retaining walls, bridges, and dams. क्या है lateral load piles? ऐसे pile the use of lateral piles are to support horizontal or inclined forces such as foundations of retaining wall, bridges, and dikes. So converse Labarre formula is neta g equal to 1 minus theta by 90 into the bracket m into n minus 1 plus n into m minus 1 divided by mn, when m is the number of rows, n is the number of piles in a row, theta equal to tan inverse of d by 3 in degrees, d is the diameter of pile, s is the spacing of piles in this group. Define site investigation. What are the different objectives of this site investigation is done? Site investigation is done for obtaining information about subsurface conditions at the site proposed construction. क्या है site investigation? Site investigation is done for obtaining information about subsurface condition at the site proposed construction. क्या है objective site investigation के? To select type and depth of foundation, to locate the groundwater level, to determine the lateral earth pressure against retaining walls, to solve potential foundation problems, to investigate the safety of existing structure, and to determine the bearing capacity of given structure. क्या है साइट इन्वेस्टिगेशन और क्या ऑब्जेक्टिव है इसके? इट इज वेरी इंपॉर्टेंट क्वेश्चन. साइट इन्वेस्टिगेशन इज डन फॉर ऑब्टेनिंग इंफॉर्मेशन अबाउट सबसरफेस कंडीशन एट द साइट्स प्रपोज साइट कंस्ट्रक्शन. जो भी साइट पे आपको कंस्ट्रक्शन करना है उसका साइट इन्वेस्टिगेशन इसलिए करते इन ऑर्डर टू नो द subsurface condition. What are the objectives of site investigation? To select type and depth of foundation. To select टाइप एंड डेप्थ ऑफ फाउंडेशन, कैसे टाइप का और कैसे डेप्थ का फाउंडेशन द सो सेलेक्ट डेप्थ का डेप्थ ऑफ फाउंडेशन टू लोकेट द ग्राउंड वाटर लेवल, ग्राउंड का वाटर लेवल कितना है वो लोकेट करने के लिए भी यूज किया जाता है। टू डिटरमाइन द लैटरल अर्थ प्रेशर अगेंस्ट रिटेनिंग वॉल, टू डिटरमाइन द लैटरल अर्थ प्रेशर, कितना लैटरल अर्थ प्रेशर है अगेंस्ट रिटेनिंग वॉल, उसके लिए भी साइट इन्वेस्टिगेशन करते हैं। टू सॉल्व पोटेंशियल फाउंडेशन प्रॉब्लम्स, फाउंडेशन से रिलेटेड जो भी प्रॉब्लम्स है उसके लिए भी यूज किया जाता है सर्टिफिकेशन। टू इन्वेस्टिगेट द सेफ्टी ऑफ एग्जिस्टिंग स्ट्रक्चर, एग्जिस्टिंग जो स्ट्रक्चर्स हैं उनकी सेफ्टी के लिए भी यूज किया जाता है सर्टिफिकेशन। टू सॉल्व पोटेंशियल फाउंडेशन पर, टू इन्वेस्टिगेट सेफ्टी ऑफ एग्जिस्टिंग स्ट्रक्चर, टू डिटरमाइन द बियरिंग कैपेसिटी फॉर ए गिवन स्ट्रक्चर, और किस लिए ज्यादा यूज किया जाता है, टू डिटरमाइन बियरिंग कैपेसिटी ऑफ ए गिवन स्ट्रक्चर। सेकंड क्वेश्चन इज डिस्क्राइब the standard split spoon sampler with need sketch. So this is a standard split spoon sampler. So standard split spoon sampler is used to obtain disturbed soil sample. It consists of mainly three parts. Standard split spoon sampler के क्या है, तीन parts हैं. Number one, driving shoe, which is 75 mm long. You see here, this is your driving shoe. ड्राइविंग शू इसका नाम इसलिए है क्योंकि यही जो पार्ट है जो अंदर जाता है। So sorry for the inconvenience caused. So the standard split spoon sample is used to obtain distributed soil sample. It consists of mainly three parts: driving shoe, 75 mm long. So this is the driving shoe. It is called as driving shoe because it is inserted beneath the earth surface. Split tube, split longitudinally into two halves, 450 mm long. Coupling at top of tube, 150 mm long. The inside dia is 38 mm and outside clearance is 50 mm. Outside clearance this is 50, inside is 38 mm. The coupling head provided with check value and four venting ports of 10 mm dia to improve sample recovery. After the borehole has been made, the sampler is attached to the drilling rod and is lowered into the borehole. The sample is collected by forcing the sampler in the soil by repeated number of blows of drop hammer. The sampler is withdrawn and split tube is separated from coupling head and driving shoe and the sampler is taken out. It is then placed in container sealed and transported to the laboratory. Explain the rotary and percussion methods of exploration and the suitability or rotary drilling method. So a borehole is advanced by rotating a hollow drill rod which has a cutting edge at its lower end. As the drill rod is rotated, the drill bit shear of the material penetrated. A drilling fluid under pressure is introduced through the drilling rod to the bottom of the hole. The fluid carrier cuttings from bottom of hole to the ground surface through annual space between the drilling rod and wall of hole. Rotary method used in clay sand and rocks. Percussion drilling method. This method is used for making holes in rocks, boulders, and other hard strata. A heavy chisel is alternately lifted and dropped in a vertical hole. The materials gets pulverized. The point where the chisel strikes above water table, water is to added to hole. The water forms slurry with pulverized material, which is removed by sand pump at regular interval. So now we will see module 2 derive an expression for computation of consolidation settlement. So the consolidation settlement at any instant of time can be expressed as SP equal to U into ST, where ST equal to total or final consolidation settlement. U is the degree of consolidation varies from 0 to 100%. Coefficient of consolidation CV is equal to TV into H into dr square by T. If U is less than equal to 60%, TV is equal to pi by 4 into U by 100 square. U is greater than 60%, TV is equal to 1.7813 minus 0.9332 log to the base 10 100 minus U. For single drainage, HDR is equal to H. For double drainage, HDR is equal to H by 2. Coefficient of compressibility AV is equal to delta E by delta P. And the coefficient of volume change MV is equal to AV by 1 plus E naught. Coefficient of permeability K is CV into MV into gamma W. SP is equal to H into CC by 1 plus A naught log to the base 10 P2 by P1. CC equal to compression index equal to E1 minus E2 log P2 minus P2 by P1. E naught equal to GS into WN. So your CC is equal to 0.009 into L by L minus 10. LL is liquid limit. A water tank is supported by a ring foundation having outer diameter of 10 meter and inner diameter of 7.5 meter. The ring foundation transmits a uniform pressure of 160 kilonewton per meter square. Compute the vertical stress induced at a depth of 4 meter below the center of ring foundation using Business analysis. So what we are trying to do, a water tank is there which is supported by a ring foundation having outer diameter of 10 meter and inner diameter of 7.5. The ring foundation transmits a uniform pressure of 160 kilonewton per meter square. What we need to do, compute the vertical stress induced at a depth of 4 meter below the center of ring foundation using business analysis. So R2 is equal to 10 by 2. Diameter is 10, so radius is 10 by 2, 5 meter. R1 is equal to 7.5 by 2. It will be 3.71. Q is 160 kilonewton per meter square. So Z is 4 meter. R1 is 3.75. R2 is 5 meter. Sigma 2 into is equal to Q into KB. Sigma 2 is equal to Q into 1 minus 1 by 1 plus R2 square because 3 raised to 2 minus Q1 minus 1 by 1 plus R1 z square 3 raised to 2. So sigma z is equal to 160 1 minus 1 by 1 plus 5 by 4 square 3 by 2. 160 minus 1 minus 1 by 1 plus 3 by 1. So sigma z by A equal to 23.11 kilonewton per meter square. So what are the assumptions made in Rankine's theory and Coulomb-West theory? So Rankine's theory assumption. What are the assumptions of Rankine's theory? The soil mass is homogeneous. Soil का जो mass है homogeneous है, dry, cohesionless and semi-infinite. Rankine's theory assumption. The soil mass क्या है? Homogeneous है, dry, cohesionless and semi-infinite. The ground surface is a plane which may be horizontal or inclined. The back wall is vertical and smooth. रैंकिन्स थ्योरी के assumption क्या है? जो सॉइल का जो मास है होमोजीनियस है, ड्राई, कोहेजनलेस एंड सेमी इनफाइनाइट, और जो ग्राउंड सरफेस इज ए प्लेन which may be horizontal or inclined. The back wall is vertical and smooth. The wall yields about the base and thus satisfies the condition of deformation for plastic deformation. Coulomb's West theory assumption. Coulomb West theory की क्या assumption है? The backfill is dry, cohesionless, homogeneous, isotropic, and elastically undeformable but breakable. The slip surface is plane, which passes through the heel of wall, and the sliding wedge act as a ridge body. The position and direction of the resultant portion are known. So next is explain the factor of safety used in stability analysis. Factor of safety with respect to cohesion. Assuming friction to be fully mobilized, Fc is equal to C by Cm, where C is ultimate cohesion, Cm is mobilized cohesion. Next, factor of safety with respect to friction. Assuming cohesion to be fully mobilized is given by F phi equal to tan phi by tan phi m. Or tan gets cancelled, it is phi by phi m. Where phi is the ultimate angle of shearing resistance, phi m is the mobilized angle of shearing. So the factor of safety with respect to strain F equal to TF by 2, where TF equal to ultimate shear strength and TF equal to C plus sigma tan phi, or tau is mobilized shear strength. Tau is equal to Cm plus sigma tan phi. So the factor of safety with respect to height is given by Fh equal to Hc by h, where Hc is critical height of slope, h is the actual height of slope, and Fh equal to Fc, assuming cohesion to be fully mobilized. Comparing Coulomb's earth pressure theory over Rankine's earth pressure theory. So how you're comparing Coulomb's theory with Rankine's theory? Rankine's theory is the soil is dry, cohesionless, homogeneous, and semi-infinite. The back of the wall is vertical and smooth. The ground surface is plane surface which may be horizontal or inclined. The resultant of earth pressure is always parallel to the surface of backfill. So how you are comparing Rankine's theory with Coulomb theory? Rankine's theory क्या है? Dry है, cohesionless है, homogeneous है और semi-infinite है. And the back of the wall is vertical and smooth. The ground surface is plane surface which may be horizontal or inclined. The resultant of earth pressure is always parallel to the surface of backfill. Coulomb-West theory. The soil is dry, homogeneous, and isotropic. The back of the wall is rough and plane. The failure surface is plane and friction is distributed uniformly failure surface. The position of resultant earth pressure and position are known. What are the assumptions and limitations of Terzaghi's analysis? Terzaghi analysis के क्या assumption और limitations हैं? Assumption: the soil is homogeneous and isotropic. First assumption है soil क्या है? Homogeneous और isotropic है. Second assumption is the strength of soil is represented by Coulomb equation. The strength क्या है soil की? Represented by Coulomb equations. The strip footing has a rough base and the problem is essentially two-dimensional. Strip footing क्या है? Rough base है और the problem है essentially two-dimensional. The elastic zone has straight bodies inclined to phi equal to psi to the horizontal and the plastic zones are fully developed. PP consists of three components which can be calculated separately and added. Failure zone do not extend above the horizontal plane through the base of the footing. Limitations क्या है Terzaghi theory है? Terzaghi theory is suitable for only shallow foundation. Terzaghi की जो theory है suitable only for shallow foundation. As the soil compresses, five changes, slight downward movement of footing may not develop fully the plastic zones. So explain the different types of bearing capacity failures. Bearing capacity failures कौन से हैं? There are three types of bearing capacity failures, namely general shear failure, local shear failure, punching shear failure. तीन टाइप के फेलियर्स कौन से हैं? जनरल शेयर फेलियर, लोकल शेयर फेलियर और पंचिंग शेयर फेलियर. So what is general shear failure? It has well defined failure surface reaching up to the ground surface. The failure is sudden with pronounced peak resistance and ultimate bearing capacity is well defined. जनरल शेयर फेलियर में क्या हो रहा? इट हैज वेल डिफाइंड फेलियर सरफेस रीचिंग अप टू द ग्राउंड सरफेस. और जो फेलियर है सडन है विथ प्रोनाउंस पीक रेजिस्टेंस एंड द अल्टीमेट बेरिंग कैपेसिटी इज वेल डेवलप्ड, well defined. Local shear failure. The failure pattern is clearly defined only immediately below the footing and the failure surface do not reach the ground surface. The failure is not sudden and there is no lifting of footing and the ultimate backcase is not well defined. Punching shear failure क्या है? No failure pattern is observed and the failure surface is vertical slightly inclined, follows the perimeter of base. The failure is observed in terms of very large settlement and the ultimate bearing capacity is not well defined. Next is explain the efficiency of pile group. When closely spaced piles are grouped together, the soil pressure develops in the soil as resistance will overlap. The bearing capacity of pile group may or may not be equal to the sum of bearing capacity of individual piles in a group. A method of estimating the bearing capacity of group of friction piles is to the quantity NQF by a reduction factor called the efficiency of pile group. QG equal to neta G into N into QF. Neta G equal to QG N into QF. QG equal to load carried by a group of friction piles. QF is equal to loads carried by each friction pile. N is the number of piles in the group. So write a critical note on negative skin friction. Negative skin friction is a downward drag acting on a pile due to downward movement of the surrounding soil relative to the pile. This happens when the surrounding compressible soil has been recently filled up with soil. As the soil consolidates, the earth fill moves downwards, developing friction forces on the perimeter of the pile, which tends to carry the pile further into the ground. The negative skin friction may also be developed by the lowering of the groundwater. Determination of magnitude of negative skin friction. For cohesive soil, QNF equal to P into LF into C. For cohesion-less soil, QNF equal to 1 by 2 into LF square into P into gamma into K into F, where P is the perimeter of soil. LF equal to depth of fill in soil which is moving vertically downwards. C is cohesion of the soil in zone of length. K coefficient of earth pressure, gamma unit weight of soil, F coefficient of friction, tan phi equal to tan angle of well friction half phi to 0.5. Design a friction pipe group to carry a load of 4,000 kN at a site where the soil is clay up to a depth of 20 meter, underlain by rock. Take factor of safety as 3. Cohesion is 80 km per meter square and check for group action. Assuming the diameter and length of the pile, assuming the diameter and length of the soil as 0.5 meter and 15 respectively, D equal to 0.5 meter, L is equal to 15 meter, alpha equal to 0.9. So individual pile QU equal to CU into NC into AB plus alpha CU bar AS. QU equal to 80 into 9 into pi by 4 into 0.5 square plus zero point 0.9 into 80 into pi into 0.5 to 15. So your QU comes out to be 1837.83. QA is equal to 1837.83 by 3. So it comes out to be 612.61 kilonewton. The number of coils is 4000 by 612.67, 6.2 device length 6.529 divided by 6 into 15 comes out to be 16.3 equal to 17. Group action. Provide spacing as 2.5 times D. 2.5 times D is 1.25 meter. Block failure QGN equal to C into NC into AG plus PG C bar L. QGN equal to 80 into 9 into 3 into 1.75 plus 2 into 1.75 plus 3 into 18 into 17. QGN equal to 5566.67 kilonewton, which is greater than 4000 kilonewton, hence same. So this completes our 8 marks question. Hope you have understood. If you have any queries related to it, you can just drop a message in the comment box, or you can reach me at nadeem@kevin.university. Even you can call me at 8553171859 during evening hours. I hope you have a good time. Thank you, one and all. So in the next class, we will see 10 marks questions. Mm, oh, explain the planning stages in subsurface exploration program. This we will see in the next class. Okay, okay. I will just clear your doubt with respect to the problem. See here, what is happening here? It is 6.529 only. QA. I just read it from this part. Sorry. Wait. Okay. Okay. QU was CU into NC into AB plus alpha CU bar into AS. So it is 80 into 9 into pi by 4 into zero point 0.5 square plus zero point 0.9 into 80 into pi into zero point 0.5 into 15. So QU is 1837.83. QA is equal to 1837.83 divided by 3. So it comes out to be 612.61 kilonewton. Number of coils is 400 by 612.61. It comes out to be 6.529. So now revised length, what we are doing, 6.2529 divided by 6 into 15 we are doing. So this comes out to be 16.32, that we are taking as 17. Providing spacing as 2.5 times D. 2.5 D is zero point 0.5. So it comes out to be 1.25 meter. Block failure QGN is equal to C into NC into AG plus PG into C bar L. So your QGN is equal to 80 into 9 into 3 into 1.75 plus 2 into 1.75 plus 3 into 18 into 70. So your QGN is equal to 5566.67 kilonewton, which is greater than 4000 kilonewton. Hence, it is safe. I hope now it is clear to you. Okay, thank you. So I am ending the meeting.